Number 1, in the right triangle, find the length of the side not given. Give an exact answer and an approximation to 3 decimal places. We've got a right triangle, and I'll attempt to draw one. Should look something like that. You've got A is equal to 3 and B is equal to 8. So either one of these sides, that's not the long one, the longest one from top to the bottom on the right, that's going to be your C that we're actually going to look for. And with a right triangle, you can use Pythagorean Theorem. And you might know this formula already. A squared plus B squared equals C squared. Pythagorean Theorem. And you can use that anytime you've got a right triangle to figure out the sides if you've got two of them. So A in this case, we're told is 3. We want to square that. B in this case, we're told is 8. We want to square that. And C we don't know, so we still leave that as C squared. So 3 squared is 9 plus 8 squared, which is 64, equals C squared. 9 plus 64 is 73, still equal to C squared. And at this point, we want to know exactly what C is. So what we're going to do is we're going to square root both sides. And on the right side, anytime you square root a square, both of those things cancel out. So we're left with just C equal to the square root of 73. This is an exact answer. So that's what you're going to want to put in the first question. So square root of 73. For the exact. And when they ask for an approximated answer, you just have to put the square root of 73 into a calculator and then see how that comes out. If you put that into a calculator, you get 8.544. So 3 decimal places rounded to the nearest thousandth. So we've got a 0 next to the 4. And since we're only going 3 decimals, we'll leave off the 0 and the 4 will stay the same. If it wasn't a 0, if it was a 5 or more, that last 4, we would actually round up. Number 2, find the length of side A in the right triangle. So I'm going to draw a right triangle here. B is 9 and C is 15. Make sure your C is the longest one. It's going to be 15. And then A, we'll just go ahead and leave as A. So since this is a right triangle, we can use Pythagorean Theorem. A squared plus B squared equals C squared. And A we don't know, so we'll just leave that as A squared. B is 9. So you want to square that, and then C is 15 squared. 9 squared is 81. 15 squared is 225. So we want to get A by itself. Ultimately, we'll start off by getting rid of the 81. A squared equals 144. We want to get A by itself, so you're going to square root in order to get rid of that 2. But if you square root on the left, you also have to square root on the right. So we've got A equals the square root of 144. Comes out pretty nicely, comes out to just 12. So they're not asking for approximations on this one. There wouldn't be anyway, it's just 12. Number 3, in the right triangle, find the length of the side not given. Give an exact answer and an approximation to 3 decimal places. So we've got a right triangle. A, we don't know what it is. B is 2, and then C is the square root of 14. Still using Pythagorean Theorem since it's a right triangle. A squared plus B squared equals C squared. A we don't know, plus B, which is 2. We want to square that. And then C, which is the square root of 14 squared, replacing C. And then on the right, remember what I said earlier about square roots and squares cancel each other out. So we've got a squared plus 4 equals 14. Then subtract 4. We'll get the a squared by itself. So we've got a squared equals 10. And then we don't want a squared, we want just a. So we'll get rid of that square by square rooting it. Square root the right side also, and we've got a equals the square root of 10, which isn't like the square root of 25 where it just turns into 5. Square root of 10, though, is an exact value. So we would put in square root of 10 for that first answer. And then an approximation, if you put that into a calculator, square root of 10 will give you 3.16227. So if we're going to 3 decimal places, look at the number to its right. If it's not 5 or more, you'll just leave the 2 as it is. So 3.162 is our 3 decimal place approximation. Number 4, speaker placement. A stereo receiver is in the corner of a 15 by 11 room. So something like this. We'll make the longer one 15, the shorter one 11. Speaker wire will run across a rug. I'll do the speaker wire in blue. It's going to run diagonally, so we've got a sort of right triangle there to a speaker in the far corner. If 2 feet of slack is required on each end. So we've got 2 feet of extra slack there, got 2 feet of extra slack there. How long a piece of wire should be purchased. So really all we need to find is this space from there to there, which is similar to what we've done so far. We just have to use Pythagorean Theorem since presumably this is a right triangle. So we've got a squared plus b squared equals c squared. And in this case, a would be either one of these sides, 11 or 15. I'll go ahead and let 11 be a. And we'll let b be 15. Going to square that. And this long side that we're looking for is c. Want to square it. So 11 squared, 121, plus 15 squared, 225 equals c squared. So c squared equals 346. And if we want to get c by itself, we're going to square root that. So c is equal to the square root of 346. And we're wanting to round to the nearest foot. So let's see what square root of 346 is. 18.6. And if we're rounding to the nearest foot, we'll go ahead and call that 19. So let me not circle that yet. So 19 is the nearest foot. And don't forget that we've got 2 feet of slack on both ends. So it turned out C was 19. And we're looking for how long the wire needs to be. So if we've got 2 feet of slack on the right, 2 feet of slack on the left, we're actually adding 4 feet to that. So ultimately we end up with a wire that needs to be 23 feet long.